Alright everybody, here we are in week 12, and I'm only going to do one day of videos this week because we are reviewing for our exam, which is during week 13, during the second day. So, which that exam is all about algebra blocks and algebra tiles. So we are not going to be doing but one day of videos, which is kind of nice. So that means we're not going to be stressing out too much, I hope, doing too much before we get into our exam. So where we're headed is we want to talk a little bit about some stuff that's called groups and rings and different properties that are algebraic properties, and you'll see them if you're going on into, say, an abstract algebra class or something like that. Just to kind of introduce the topics, make sure everybody knows their properties. Whenever you see the state board exam, one of the things that I think students who are about to take their state board exams mess up on is not knowing properties, like what's the difference between the associative property and the commutative property. You probably know it, but you may not know it like cold. You may not know exactly what's what. So to help you out, we're going to talk about a little bit of that. But I thought I'd say that for after exam 3. And that'll be the last little bit of new material. And for this one day week, we're just going to do clock arithmetic. So clock arithmetic will actually kind of lead us into all those other topics, groups and rings and stuff like that. So just as an idea of what clock arithmetic is, I have a lovely clock here. I'm not a great artist, so this will be 12, this will be 3, this will be 6, and this will be 9 right here. So as we go through, we're going to just kind of talk about what clock arithmetic is. So we know that we start our day each day at what's called 0000. So at midnight, the clock starts over, basically. And if you're working in military time, in fact, they use a 24-hour clock, meaning that at noon, they don't start back over, they just keep going. So at 12 o'clock, instead of going to 1 o'clock p.m., like we do in everyday life, the military goes to 1300. So they use a 24-hour clock, and interestingly, their arithmetic would be based on a 24-hour cycle. So for us, though, most people in daily life start back over at 000 every 12 hours. So what I mean here, what happens throughout the day is, okay, say I start at midnight, it's 0000, that's the time. And then I come out here, that's 3 a.m., 0300. Here it would be 0600, here it would be 0900, and here, right at the top of the thing, if I went all the way around my clock once, that's 12 hours, we would now be at what we normally call 12 o'clock noon, okay, or 12 p.m. And then a funny thing happens. We start back over, right? 1, 2, 3. Those are all in the p.m.s, though. 1, 2, 3 p.m., 6 p.m., 9 p.m. until we get to 11:59 p.m. and then we hit midnight, and again the clock resets. So think about the clock resetting. That's what I want you to do. Think about clock resetting. That's what we call it. To 0000 every 12 hours. Okay, so if I wanted to do something, I wanted to talk about a particular time, then even adding hours, so we'll think about it as hour arithmetic. Hours being added, multiplied, whatever. We're normally going to do added, so that's the operation I'm going to start us with. But say that it's like 8 a.m. And I say, okay, well, let's add 3 hours. Okay. Well, what the heck happens there? 8 a.m. plus 3 hours. You could literally turn that into 8 plus 3. Okay, we're just going to count them as hours in and in and of themselves, and that would be 11, right? So we would know that's 11 hours past midnight, or 11 a.m. is what we know that to be. In the arithmetic, clock arithmetic, though, we're going to call it this lovely thing. It's going to be 11 modulo 12. Okay, so you're going to start seeing this word modulo, or the abbreviation for that will be MOD, mod, and I'll start using that pretty quick. So, or 11 mod 12. Okay, and what that means for me is that whenever I'm looking at things in terms of 12 hours, a 12-hour cycle, a 12-hour rotation, then I'm always going to go back and say, okay, 11 mod 12, that is, basically the 11's like the remainder that's left over. It's just that whenever I do 8 plus 3, I didn't go over the 12, so it's not a remainder bigger than 12, right? So let's do a little bit different. What if it was 8 a.m. and I added 5 hours? Not that much difference, right? That would be 8 plus 5. That would be 13 hours, let's put it that way. Okay, 8 hours past midnight, that's what that means, right? Right there, this is 8 hours past midnight. And we're going to add to that 5 more hours, okay? That would be 13 hours, right? But we know that normally, unless you're in military time, if you were in military time, you just call it 1300 and go on. But even in military time, they're just going to do a 24-hour cycle, right? Every day starts over, no matter what time, what kind of time we're keeping up with. So they would just go on a 24-hour cycle instead of a 12-hour cycle. So we know we're not going to normally call this 13 o'clock, right? Or 13 hours. Instead, we're going to change that to 1 o'clock p.m. And the question becomes, how do they do that? Like what kind of stuff happens? Come back here to my clock. Let's do this. I was at 8 a.m., right? And then I added 5, and basically that took me beyond the 12 to the 13 right there. But we know we don't call it that. We call it what? 1 o'clock, right, in the afternoon. So what we did was, as soon as we went around and we passed noon, or we passed that 12-hour mark, we subtracted out the 12 and we called it 1 p.m., right? That's what we would normally call it, 1 p.m. But down here, we're getting away from the hours thing, the AM, PM, all that, and we want to just do this arithmetic as a modular arithmetic. So, and again, modulo meaning in cycles. So 13 minus 12, I'm pulling out the 12 because it was a 12-hour cycle, right? To get all the way around the clock and then start back over. So we know that's 1. But my answer wasn't really 1, right? My answer was 13. I've just done a little bit of arithmetic here, and I'm calling it a 1, and so I need to let people know what kind of 1 that is. It's a 1 mod 12. And whenever I see that, in Webster brain, what I think whenever I see that is, that's a remainder of 1 on a base 12 cycle. Remainder of 1 on a base 12 cycle. Okay, so let's do another one. 1 mod 12, that's what that means. Let's do another one to make sure we can do it. How about 7 plus 8? Nope, I don't want to do an 8 because I've done an 8 twice. Let's do 7 plus 9. Okay, and this is going to be in mod 12, or in a cycle of 12. Okay, so we'll call it mod 12. So we know how we're doing this. So 7 plus 9, well, 7 plus 7 would be 14, and 2 more, so that would be a 16, right? Okay, However, I know if I start thinking about this, like I said a second ago, a base 12 cycle or a base 12 system, surely you've seen some base 10, base 4, base whatever before. If it was in a base 12 system, that's the modulo thing, okay, mod 12. So I know 16 is way bigger than 12, right? So that's not one of my answers in base 12. I need to do some subtraction here and make that look like an acceptable number in the mod 12 world. So I'm going to subtract 12 because I know I went past the noon hour, right? And I've gone 4 more hours, right? So 4 mod 12 is the answer there. So the process there is that I'm subtracting out the 12 because the number was bigger than 12. So I'll do some in a second where the number is actually smaller than 12. But I want us to get used to these first. So here we go. Let's do one more. Let's do 6 plus 11. 6 plus 11. So on the clock that would be like 6 a.m. plus 11 more hours. Well, in our brain, we probably know what that is, right? 6 a.m. If it was 6 plus 12 hours, it would be 6 a.m. or it would be 6 p.m. then, right? So it would still be 6 though. But it's 6 plus 11. So in my brain, I'm thinking, I think that's about 11. But let's check it and make sure. 6 plus 11 is 17. That's a base 10 number, right? I want to pull out as many 12s as I can because I know, hey, I already went past that noon hour, right? So pull out as many 12s as I can, and I get a 5. And again, it's 5 mod 12. Okay? So I'm kind of using some stuff a little bit interchangeably, and probably nobody's freaking out on me about it. But I want to make sure everybody understands what the heck's going on when I say base 12. So for just a second, I'm going to digress, and I'm going to talk about base 10, because base 10 is the system we're in. And there's a lot of thoughts on that, like if you go in a history class, why do we work in a base 10 world? And a lot of people just think it's literally because we have 10 fingers and 10 toes, right? So originally when cavemen wandered the earth or whatever, the thought was they just counted by tens because that was like the built-in manipulative that they had with them, right? Okay, so they had those fingers, so they used them to count. And so every time they got a group of 10, they would start over because they only had 10 fingers. So that's kind of the idea that people usually give for base 10, why that number works, but it actually is quite a lovely base for us. So just so we remember, base 10, and we had some dividing stuff earlier in the semester where we did base 3, right? So hopefully this starts tying in a little bit. But whenever I do base 10, I know the place values, right? I know this is 10 to the 0, 10 to the first, 10 to the second, 10 to the third, 10 to the fourth, right? So anything to the 0 power, that's a 1. So this is the ones position. 10 to the first, that's a 10. 100, 1,000, 10,000. Okay, so we know all of our place values that direction. We also know behind the decimal point we get a 10 to the negative 1, 10 to the negative 2, and so on. That's the 1/10th position, and that's the 100th position, and yada, yada, yada. So hopefully that kind of sounds familiar with your place values and stuff like that. But what I want to get to is what the heck happens like if I do the number, if I write for you the number 21, first of all, that's a base 10 number, right? We just don't normally write the base 10 down there because we assume it's base 10 because that's the numbers we work in all the time. But this would be 21 base 10. Okay. And what we would end up saying is, what the heck happened here? So I had enough 10s to fill it up the tens position twice, right? So 2 whole times, that's a 10 plus a 10. Let me put that out there. 10 plus a 10 plus a 1. So this is like I'm running around a clock, but the clock only has 10 numbers on it instead of 12 numbers, okay? So my cycle goes to 10, and as soon as I hit 10, it starts back over, okay? Then I get another 10, and it starts back over. So 1 would be the remainder here if I did this as a mod 10 number. Okay, so I would pull out all the 10s possible, and I would be left with a 1 left over, and that would be a 1 mod 10 number. So it's related to the bases, but it's not quite exactly the same as the bases. The other thing that we should know is that in base 10, any base 10 number, we are allowed the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? Because those are the digits that we can use in order to fill in one place value, right? So all of these can go in my 1's position, but then once I got past 9, what would happen? I would go to 10, right? 10 would be a combination of the number 1 and the number 0, those digits. Okay, that's how I get something, well, here it is right here. That's how I get something that looks like this in base 10. And basically what we're saying is I have 1 group of 10s and 0 groups of 1s, right? So that would be some combination of the 2 digits that I have down there. And then I would start back over, like what's the next thing can go in the 1's position? Well, I would start back over. There's a 0. The next one is a 1. The next one is a 2. The next one is a 3, and so on. Okay, so for our purposes in base 10, that's what we're used to looking at. And it's important to notice that the 9 is the biggest digit that we're allowed, and it's 1 less than 10, which is the base that I'm working in, right? Okay. So I'm going to extend that a little bit, and we're going to talk just slightly about base 12. And this actually goes for any base that I'm talking about. I'm just picking 12 because we just talked about base 12 when we were doing clock arithmetic. So I'm not going to worry about place values or anything like that, but I want to worry about what kinds of numbers I'm allowed in base 12. So my digits, so to speak, before we get to 12. And have to start our cycle over. Okay, that's what I'm worried about. What are my digits that I'm allowed before I get to 12 and I have to start my cycle over? Well, of course there's a 0, although a lot of times we don't think about 0, but he's hanging out there, okay, and he can fill a mod, right? For instance, if it was exactly noon, 12 o'clock p.m., and I pulled out a 12, what would that be? 12 minus 12 would be 0, right? So it would be 0 mod 12 to represent the noon. So I have to know that 0 is a possibility, okay? 1, 2, 3, 4, 5, 6, 7, 8, and 9. Does it stop there? Well, no, it doesn't stop there, right? Because I got to go all the way around the clock. So we know we also have a 10 o'clock, and we also have an 11 o'clock before I get to 12, right? The 11 needs to be my top possible placeholder or filler for this, for anything I'm doing in base 12. And whenever I do mod 12, it's going to work out the same way. So remember earlier, let me stick this back up here. We did 8 plus 3 equals 11, and we had 11 mod 12. That means 11 when I'm running on a cycle of 12. I'm almost to the end of my cycle, right? I'm almost to noon or midnight or whatever to start my cycle back over. I'm just not quite there. So I'm going to have 11 mod 12 there. So 11 is a perfectly acceptable answer. And in fact, I need the 11 because he's going to be 1 less than 12. See, the 9 was 1 less than 10. The 11, let me write that there so everybody sees it. This is 1 less than 12. Everybody knows that that's 1 less than 12. We all know 11 is 1 less than 12. Duh. Okay, that's not what I'm saying. I'm saying those are the relationships that are important to us for this. So let's think for a second in military time. Whenever I'm dealing with the base 24, if you were dealing with military time, you start over only at the midnight mark, right? Okay, so what placeholders or digits, are we allowed? That's what I want to know. Of course, it's all of these. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, but we don't start back over at noon in the military time, right? We go on to 12, and then they keep on going. Like I said before, 1 o'clock would be 1300, 2 o'clock would be 1400, and so on. 15, 16, 17, 18, 19, 20. Think about it for just a second. What is 2000 hours in military time for us civilian folks? It would be 20 minus 12, which would be what? 8 o'clock, and that would have to be PM, right? Because 0800 down here would be the AM hours. So that would be 20 minus 12, 8 o'clock, okay? 21, 22, 23. 23 minus 12 is 11. So this would represent 11 p.m., right? And again, I'm not going to go all the way to midnight because that would be 24. I'm not allowed the 24 because I'm in base 24. So again, this guy right here is 1 less than 24. Okay, so I think we see the pattern that's coming in there. This actually happens for all kinds of bases. So if you were in a class before, you might have had to have done something like base 4. Okay, those digits are actually nicer and easier for me because it's 0 and then what? 0, 1, 2, and 3. Okay, and again, that guy is 1 less than 4. Is my top number. Okay, so what I want to point out though is that even though I'm stopping at one number less than whatever base I'm working in, I still get how many digits or placeholders here? 1, 2, 3, 4. There's still 4 there. Think back here. There were 23 plus the 0. That's 24. Okay, so 24 possible numbers in base 24, right? What about here, base 12? There were 11 plus the 0, that's 12 possible numbers. It's not by accident. We stop one number short and we have this 0 to place hold. So it's always going to be 1 short and then we add 0. So we have a total number. What was it in base 10? 9 plus 1, 10 possible numbers, right? Yeah. So it's going to happen all over the place. 4 possible numbers for base 4. It's not unusual and it's actually by design. So be aware that that's out there. It wouldn't matter if I told you base 6, you would know, hey, I got 6 possible numbers, there's 0, and then what? 1, 2, 3, 4, 5, and I'm going to stop 1 short of whatever base number I'm on, or base number I'm in. So that's just the way it always works, no problem. Alright, so my question is, we talked about bases a tiny bit at the beginning of the semester when we were doing divisibility. The question is, okay, how does this work for me in clock arithmetic? Because we're not always going to be in clock arithmetic means specifically the 12-hour thing or the 24-hour thing. But we're not always going to be in there for the 12 hours or the 24 hours. So you'll have some questions on your homework that are not base 12 or not base 24. Instead, the questions would be considered modular arithmetic. Okay, that's the way that they think about it, modular arithmetic. So we might be out of base 12. Before I go too far, though, I want to go back and so all these answers will be related to whatever system, I'm going to call it a modular system, we are working in. What that means is, before you can give me an answer, you have to know what modular system we're working in. Okay, you can't just come up with it out of the air, because clearly the answers, well, let's do a couple. So a minute ago we did mod 12. We did mod 12, 6 plus 11, right? Okay, so I'm going to do that, but I'm going to do it in, let's do mod 4. Work in mod 4, and we're going to do 6 plus 11, but we're going to do it in mod 4 this time. So 6 plus 11 in mod 4. It's still 17 whenever we do the arithmetic in base 10, right? Okay, so we still start out with regular old base 10 arithmetic and figure out what our number is. But I need to subtract out as many 4s as I can, right? So I know you can probably shortcut this, but I'm going to do it the long way, and then we'll talk about how you could have shortcutted. Minus 4 would give me 13. Minus 4 would give me 9. Minus 4 would give me 5. I'm going to, sorry, I'm out of space. 5 minus 4 would give me a 1. Okay, so I'm going to suck out as many of those 4s as I can. And whenever I finish, I'm going to have a 1. And what am I going to write behind it? 1 mod 4. Okay, 1 mod 4. So first of all, let me compare and say, hey, when I did this problem earlier in mod 12, 6 plus 11 was 17 minus 12, 5 mod 12. But here when I do this problem in mod 4, 6 plus 11 is 17. I pull out all the 4s, I get 1 mod 4. That is not the same answer. And it's based off of what? The fact that I'm going through a different kind of cycle, right? Here I'm only rotating up to 4 before I start over. Here I get to go all the way to 12, all the way around the clock before I start over. Okay, so here I'm really going through my cycle a lot faster, right? Because with 17 I could only pull out 1 12, but here with 17 I could pull out 4 different sets of 4s. 1, 2, 3, 4, right? So that's what's kind of going on there. Is it's just a matter of how big my system is that I'm working on, how big is that cycle before I repeat, start over. So mod 4, definitely a different answer than mod 12. And what do you think if we had done mod 5? Yeah, it would be a different answer. If I did mod 10, by the way, I'd pull out as many 10s as I could out of 17. I'd have a 7, right? Still another answer. So what I'm getting at there is it depends what mod you're working on. So as you work through your homework questions, I'm going to have to tell you what mod you're in. Okay, be aware of that. All right, so that's a lot of arithmetic, adding stuff. What I haven't done yet is I haven't done any subtracting stuff. So let's go back to mod 12. I realized I had not come back and done these subtraction problems. And let's do 4 minus 2. Mod 12. 4 minus 2. That's just a 2 in base 10, right? And what I'm going to ask myself is 2 an okay answer in base 12? Okay, and the answer is yes. All my digits there, all my placeholders that are acceptable are 0 through 11, right? And 2 is in that group. So I'm okay. So all I have to do is let people know is, hey, yeah, 2 is an okay number, and don't forget we're working in mod 12. Okay, that's not so rough. That's okay. But what if I had something like this? 1 minus 4. Well, what the heck's going on there? 1 minus 4. That's a negative 3, right? Is negative 3 okay in base 12 or in mod 12? Heck no. I don't have any negative placeholders anywhere, right? Go back to our mod 12 stuff, the answers that are okay in base 12. All of these are positive numbers, right? 0 through 11. So now I can't use a negative number, so I'm in trouble. So what I want to do here, if I did the same arithmetic I've been doing so far, which is to subtract 4 or subtract 12 here, do I want to do that? Negative 3 minus 12? No, because that still gives me a negative answer, right? Negative 5. So let's think about it for just a second. this is like saying, let's look at this problem. I was at 1 o'clock, right here on the clock. I was at 1 o'clock and I subtracted 4. 1, 2, 3, 4. Negative 3. So it's like I went before midnight 3 hours, right? Okay. So before midnight 3 hours, that's all fine and dandy. Negative 3, we get that. But we know negative 3 isn't a clock time, right? We can't call it negative 3. Instead, we'd have to say what? 9 o'clock. Well, how in the world can we relate that to the negative 3? And the answer is, if we had gone all the way around, it would have been 12, but then we subtracted off the 3, and that gave us the 9, right? So we actually, from the 1 o'clock, we subtracted the 3, but we weren't really worried about the 1 o'clock, right? We were really worried about the midnight and the fact that we would have had to start over there, okay? So I'm at negative 3 hours before the midnight, and that's 9 o'clock, okay? So I want to think, how in the world can I show that? Okay, and I need it to be a positive answer, so instead of subtracting the 12, I'm going to think, can I add the 12? Is that okay? Yeah, because it's basically the idea of I was at midnight and I subtracted 3, right? And I got the 9. So it's a little bit sneaky here because we're thinking to ourselves, what are we utilizing here? A negative number plus a positive number is the same as subtracting those two numbers and taking the sign of the bigger number, right? Which we talked about that a lot while we were doing algebra blocks, right? So we've seen this process going on, and we know those are equivalent. And in fact, we kind of showed it, didn't quite prove it, but we kind of showed it using the algebra blocks, right? So we know those are equivalent. So yeah, I can add the 12. So basically what we're thinking is, if we started at at midnight, and I added 8 hours, that's equivalent to starting at midnight and subtracting 4. Okay. Or starting at midnight and adding 6 hours is equivalent to starting at midnight and subtracting 6 hours. Okay, so the kind of cool thing is it doesn't matter which direction I go, and I'm not going to call that a negative 6, right? I'm just going to call it 6 o'clock if I subtracted 6 from the midnight. Okay, so it doesn't matter which way I go. It's kind of a way to make these answers be positive for me so that they're positive hours on the clock, basically. All right, so how in the world would that work out? Let's do one that's let's do mod 4 because it's sitting there. Mod 4 question. Okay. And let's do 3 minus 8. Okay, what is that? 3 minus 8 is negative 5. Clearly it's in a negative direction, so, oh, I didn't give an answer here. I'm sorry, guys. That would be, I said it, but I didn't write it. 9 mod 12. Everybody okay with that? Sorry about that. I just saw that I hadn't written an answer. All right, so here I am. Sorry, start over. 3 minus 8, I do that arithmetic in a base 10 manner, I get a negative 5. But then I say, wait a minute, I want to work in mod 4. So the question becomes, hey, can I subtract 4 off of that? No, because that still gives me a negative, right? I want to add 4 onto it. So negative 5 plus 4 is negative 1. Oh, no. I still have a negative answer there, right? It's all right, because we can work with that. I still have a negative answer. I can repeat my process, right? Okay, so let me add 4 again, and what in the world am I going to get there? A 3. Now, the interesting thing is, this is actually the thing I started with. Let me write 3 mod 4 before I forget. It's actually the thing I started with, and the reason why it worked that way is because 8 is a multiple of 4, right? So I subtracted out, and then when I started adding back on, I got back to where I started from. Okay. All right. I was going to say earlier there are probably shortcutting ways that you can do this. So for instance right here, if you had -5 and you knew you were in mod 4, okay, and I know 5 is bigger, the absolute value of 5 is bigger than 4, so I know it's going to take more than just adding 1 4. I could add 2 groups of 4, right? Or 2 times 8. Yeah, totally. -5 plus 8, that gives me a 3. Okay. You could have done the same thing. Let me switch back up here again. We could have done the same thing up here. Instead of subtracting 4, 4, 4, 4 over and over again, I could have done, let me grab a different color, 17 minus 4 groups of 4, right? And I know 4 groups of 4 is 16. That would have just been a 1 mod 4. So what we see is that this repeated subtraction thing, or this repeated addition thing, I can kind of turn it into a multiplication or even a division, but I'm probably not going to use division in here. Probably going to be a multiplication. Okay, so I could have subtracted out the 4 times the 4, or we could have just said, hey, what's the biggest multiple of 16 that I can pull out of 17? I'm sorry, I said it. What's the biggest multiple of 4 that I can pull out of 17? Well, it's a 16, right? Which is equivalent to 4 times 4. So we know that. Okay. So we can always do that. Use that little property, those little properties we know if we see to use them. If we don't, we could just do it piece by piece. What if I had thought the biggest power or the biggest multiple of 4 that I can pull out of 17 was a 12? That would have been okay, right? Start with 17 minus 12. Let me put it up here. Oops, 17 minus 12. I would have gotten a 5, and then I would have had to stop and think to myself, wait a minute, 5 isn't one of my mod 4 numbers, right? I can't use it. It's got to be 0, 1, 2, 3. That's all I get. So then I would just keep on going. Subtract out another 4, and I'd get to the same answer. Okay. So the idea here being that any of my mod 4 numbers, or mod 12 or whatever, have to be equivalent to a number that I will use if I was doing base 4 or base 12 or base whatever. I can't suddenly use some number that's not in my system. Okay? So here we go. Here's a mod 12 question. And it looks a little bit different. What if I was doing the problem 8 times 4? 8 times 4. Well, if I do 8 times 4, that's certainly going to be a big number, right? Okay. So 32 is way bigger than any set of 12s that I'm allowed to have, right? Okay. So I can subtract out as many 12s as I want. Minus 12, minus 12. Okay. That's a 24. And in my brain I say, okay, 32 minus 24, or you could have done 2 groups of 12 or whatever. 32 minus 24 is going to be an 8. Is 8 an okay number, mod 12? Yes, it is. So I'm going to say 8 mod 12 and be done with it. Okay. So just in case you wanted to know, I could say, I mentioned that we could do division, but I'm probably not going to do it a lot, but it's out there, so I want you to know it's out there. You could have said, okay, look, I know I'm pulling out groups of 12s, right? I'm going around and around that clock. I'm pulling out as many groups of 12s as I can. And so I know 12 will go into 32 2 times, and I'll have a remainder of 8. Okay. I said before, what I'm looking for, I don't care how many times I go around the clock. That's not what matters to me. What matters to me is that I have a remainder of 8. That tells me where I stayed, right? So let's think about it this way. We were at 32, so let's think 32, 12, 24, 32, okay? And then I need to subtract out as many of those as I can. Well, that was a 24, so I went all the way back around the clock once. Okay, or you could just think 12. We don't care that we went around it once, right? 24, we don't care that we went around it twice. What we care about is where it ends me up at the end of the whole entire cycle. which was 8. Okay, so pull out 2 cycles of 12, and what I'm left over with is an 8. Okay, so that's kind of the idea here with the remainder of 8. That remainder of 8 is what tells me this is 8 mod 12. Done. Okay, so pretty cool stuff there. It's not too bad. What we're going to do, yeah, I think that's about it. What we're going to do next, I will show you just a tiny piece of where we're headed for the rest of the modular arithmetic. Let me show you the modular arithmetic. Trying to kind of decide on a cutoff point because we're going to do some stuff after test 3 that's going to be very group oriented, property oriented, and I don't want to get too far out. So there is going to be something that looks kind of like a table, and we're going to fill out what they call, so fill out an operation table is what they'll call it. And I'm going to keep this one small. They call it, I'm going to use Z4, so, and I'll talk about that. That's basically going to be the set of numbers that works mod 4 or base 4. Okay, so 0, 1, 2, and 3. Okay, and then I'm going to see these lovely tables that pop up, and I'm going to do the addition one. Okay. And what we're going to realize is that for the modular arithmetic, what I want is always the set of remainders. That's what we were talking about. So what's going to happen in this particular addition one is I'm going to have 0, 1, 2, and 3 going down the side. And then I'm also going to have those numbers coming this direction. 0, 1, 2, and 3. So we'll have this lovely little grid table going on where we'll see, hey, add those things together. Okay, and sometimes it's not a big deal. It's easy to fill in, and then sometimes you're like, what in the heck? Okay, so sometimes I'll have to use that remainder idea. So fill in with the remainders. And that can be either a subtraction or a division problem. Just stick one of those on your homework assignment. So it doesn't matter to me which way you think of it, is the subtraction or the division, as long as you can kind of show me your work and see what's happening. So notice that my operation here, oops, I left off my quotes, operation table. My operation here is add. Okay, it could have been subtract, it could have been multiply, it could be whatever they tell me to, because we have 4 operations, but a lot of times they're going to be add. You're going to see that from time to time. So let's do it. And whenever I see this, I'm looking at Z4, which tells me I'm in mod 4. Also, the fact that I only went 0, 1, 2, 3 and 0, 1, 2, 3 also tells me I'm in mod 4, because I can tell those have to be base 4 numbers, right? Okay, so 0 plus 0, I'm going to use this as a grid, and basically I'm going length times width to see what, or length plus width in this case, to see what should fill in. 0 plus 0 is a 0. 0 plus 1 is a 1. 0 plus 2 is a 2. 0 plus 3 is a 3. That's easy enough. I'm going to do the column also. 0 plus this 1 is 1. 0 plus this 2 is 2. 0 plus this 3 is 3. So the 0 guy is pretty nice and easy to fill in. That's not such a big deal. But here I'm going to run into some issues. 1 plus 1, that's a 2. 1 plus 2, that's a 3. No worries. But look here, 1 plus 3, that's a 4. I want to write a 4 there, and I know I'm not allowed to write 4 whenever I'm dealing with mod 4 or base 4, right? So I can't use a 4, so what do you think goes there? Yeah, it's going to be a 1, right? So, oh, I'm sorry. Not a 1. let me not jump the conclusion here, actually. What would it be? I want a 4. but I'm in mod 4, so I'm going to subtract off the 4, a 0. All right. A lot of times I'll end up with, especially with the arithmetic ones, where I've got all of the digits here, but not always. Sometimes weird stuff happens, so don't just expect that that's going to happen. It will for me here because these are nice, pretty numbers, but just keep it in mind. It doesn't always happen that way. 2 plus 1 is 3. 2 plus 2 is 4, but we already said we can't pull out the 4. We can't write the 4. We've got to pull out a 4, so I've got 0 mod 4. So I'm going to put a 0 there. And then what about this one? 2 plus 5 is, 2 plus 3 is 5. And in my brain I'm thinking, oh, 5 minus 4 is 1, right? That's what I tried to say a minute ago. I jumped the gun. Okay. 3 plus 1, so that's the remainder. We know in base 10, 2 plus 3 is not a 1. But in mod 4, modulo 4, it is a 1, right? Okay. 3 plus 1 here, that's a 4. We know. We don't want the 4. We're going to subtract it out. Make that a 0. 3 plus 2, I said that was 5, but 5 minus 4 is a 1. Put the remainder in there. Fill in with the remainders. Don't you dare write a 5 there. We're not allowed to write 5 because we're in mod 4. 0, 1, 2, and 3 are my only numbers. And this one, we haven't done this one yet. 3 plus 3, that's a 6. What do you think? I think 6 minus 4 is a 2. All right. So there is my table, my operation table, all filled in with what numbers would go there if I added mod 4. Okay. So real quickly, let's do another one. This one's fun. This one's binary. So if you've done computer science stuff and you've seen binary stuff, it's kind of interesting. Z2. What do you think in mod 2 my numbers that are allowed would be? 0 and 1, right? That's all you get. 0 and 1. Okay. So do an arithmetic operation table for mod 2, or what's called the binary system. Do I need a 2 out there? No, because I'm only allowed 0s and 1s. If you're looking at the circuit board there with 0s and 1s, a lot of times they'll say that it's either on or off, right? Okay, 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 0 is 1. And then be careful here. 1 plus 1 is 2, but I'm in mod 2, so I'm not allowed to write a 2. So 2 minus 2 equals 0 mod 2. That's what I'll put there, right? All right. So what you're going to see on the homework for this set is just a little bit of modular arithmetic. Can you do add, subtract, multiply, and then put numbers into the mod that I want it to be in, modulo. And then you're going to see some of these operation tables. So see how you do with that and which numbers you can figure out and which numbers you can't. And then for the next week, we're going to come back and we're going to figure out, all right, how does that help me with all my different properties, the commutative property, the associative property, all that kind of stuff. All right, that's it for this week's videos. Yay, just one. See you later. Good luck on test 3.